Hello friends, and welcome to this video again. So we were discussing about the graphical derivation of these equations of motion. So out of three equations of motion, we have already derived these two. You can watch them in the earlier videos. So V equal to U plus AT and S equal to UT plus half AT square, okay? So the third one we will be deriving in this particular video. So let's start how we can derive it, okay? So I have drawn here the same figure here about the motion of this object in consideration. So OP as usual, OP is the initial velocity represented by U, okay? Along the x-axis, it's the time, okay? And QR is the final velocity, which is V. So we have to derive this particular relation. And once again, let us consider the distance, how much distance the object has covered during this time t, and when it is also moving with an acceleration of a, okay? So again, as we have already learned in the previous video, that the distance traveled can be calculated if we can measure the area under this particular plot, okay? The area of this particular space, if we can calculate, that would give us the distance. So this figure, okay, PQRO, we have to calculate its area again. But if you see here, PO and QR, these two sides are parallel, okay? So such structures are called trapezium, okay? Trapezium in geometry, trapezium, okay? So now we have to, we should recall the formula for area of a trapezium. Okay. So what is the formula for area of a trapezium? So here the trapezium is PQRO. What will be its area? Let us, okay, area. Let us recall the formula. The formula of area of a trapezium is the summation of the two parallel sides. Okay, what are the parallel sides here? PO and QR. These two are the parallel sides. So you add them, PO plus QR divided by 2. Okay, this is O, multiplied by the base of the trapezium. The base here is OR. Okay, so you have to remember this formula. So area of this trapezium is PO plus QR divided by 2 multiplied by OR. Okay, now just substitute the values. Let us see what we get. So area of PQ arrows, it simply gives us the distance which the object has moved. Okay, so PO is nothing but U, initial velocity, plus QR is final velocity V, okay, divided by 2 multiplied by OR is equal to T, the time for which the object has moved. So now what can we do next? Let us substitute the value of T from this equation, the first equation, okay? So first equation, let me write it here. V is equal to U plus AT. So what will be the value of T from here? That will be V minus U divided by A, okay? V minus U divided by A, that will be the value of T, okay? So let us see what we get further. So it's V plus U divided by 2 multiplied by T value is V minus U divided by A, okay? So S equal to, so V plus U multiplied by V minus U, that gives us V square minus U square. 2 multiplied by A is simply 2A, okay? So what do we get from here? So V square minus U square is equal to 2AS, okay? Or in other words, V square is equal to U square plus 2AS. So this is the third equation of motion as we had to derive, okay? This one we have derived. So have you seen, this is quite simple. You have to just calculate the area of this trapezium, okay? area of the trapezium. So if we can calculate that, that would give us the value of the distance. Okay, so area of trapezium formula you employ here, PO plus QR. Okay, PO is U, QR is equal to V divided by 2 multiplied by OR, the base. Okay, so then T value you substitute from the first equation of motion. Recall the first equation of motion, T value substitute, and eventually you simplify and you get the third equation of motion. So now I'm going to show you another way of finding the third equation of motion, the non-graphical way. So, okay, let us just show it very simple. So you see we have already this V equal to U plus AT, right? The same equation we already have got. And we have here V square is equal to U square plus 2AS. So can we just square this equation on both sides? Let us check what happens. So V square is here on the left hand side. So let us just square it. V square is equal to U plus AT whole square. Okay, let us see just what happens. So it will be V square is equal to U square plus twice U80. Okay, A plus B whole square formula, you just employ it here. And then we have A square T square. Okay. So you see, compared with this equation, V square is equal to U square. So we already have got V square equal to U square plus another term, additional term. So is this term equal to 2as? Can we make it equal to 2as? So let us check. V square is equal to U square plus, can we take 2a common here? 2as. Okay, let us take 2a common, suppose, and let's check what happens, what we are going to get finally. So with 2a common, it will be ut plus a square t square. So a square t square, and here we have 2a, so 1/2 will be there. A square, so here there is only one a, so 1/2 multiplied by a t square. So t square term is not here, also not here, so you can multiply t square here. Okay, so what we get finally is equal to V square equal to U square plus twice A multiplied by UT plus half a T square. So what is again UT plus half a T square? Come to this equation, you check here. UT plus half a T square is nothing but S. Okay, so in place of UT plus half a T square, just put S. So this way we are also getting the third equation of motion. Therefore, we have seen that the third equation of motion can be derived by these two ways. One is the graphical way and another one is the simple analytical way, which can be obtained by just squaring the first equation of motion, V equal to U plus AT. And the value of S can also be found out here in the course of simplification of this equation, and we will eventually get the third equation of motion. So I hope you have understood the derivations, both derivations, and I hope this video has been helpful to you. Thank you very much for watching, and see you in the next video. Thank you.